All right, so if we want to graph this using Desmos, how do we input that information? The other day? A list, right? So L1 equals, and you have to use which? A square bracket or a parenthesis? Square bracket, good. So then what'd you get for your differences when you put them in your calculator? Whoa, whoa, 2, 2, 0, -2, 3, 1, 0, whoop, 0, 2, 0, 2, 1, 2, 1, -1. And what? Yeah, 0. Should have another one. Were there 3 2s?
Yeah.
Whoops. How many elements? That's a good check right there, okay? So what kind of graphical display should I use? What kind of data is this? Quantitative, right? So we can either make a histogram or we can make a box plot. A lot of times I like to look at the histogram first. Okay. Think I should change the bin width, or is that pretty good? Pretty good. What kind of distribution does it look like? It looks like there's a tail on the left. You notice what we're graphing? The differences, right? We're graphing the differences only. Okay, that's important. So go and draw that on your paper. So the question was, should we make the box plot? I said yes, because this is skewed. If you're reporting out the information, you would actually have the box plot. I would leave this though. If I were presenting this information, I would show this distribution because we're trying to satisfy our conditions, right? So unfortunately, this is left skewed, right? It's left skewed. So I will make the box plot. And if you notice, the box plot is over top of it, so I'm going to turn that histogram off. Do you have any outliers? No. And then, because of you the other day, we learned that quick way to get all that information. It was stats L1, right? And look, it gives us the quartile 1 is at 0, the median's at 1, quartile 3 is at 2. Why is that important? Well, because we're supposed to report out the what? If it's skewed, you report the inner quartile range, which is Q3 minus Q1. So that range is 2, which I can see visually right here with the box, right? It does that because of like this board being connected. I'm sorry, please just keep beeping. I have no way of figuring out when it does it or why it's doing it. Y'all are impersonating it. Okay. We can have a competition. Who can do it the best?
There's no y'all in this?
It's just one person? Okay, what else are you supposed to report? So remember, you report the measure of center, how spread out is the information, right? Any outliers? Yep. Shape is first, so that's why I looked at the distribution, right? So shape, are there any outliers? Are there? No, there's no dots. This out, there's no dots anywhere, right? Okay, that's why I really like it. Desmos, that is so quick, you know, to be able to see that and zoom in and out. And then measure of center then would be the median. So the median for this data is a 1. Okay, so that means the majority of these players, 50% of them were below the 1, 50% are above the 1, right? So that's not measure of center. That average is actually 1. Which means what about the data? What? Whiskers, yeah. 25% are from here to here. Which is why that histogram looks that way, right? Because it's skewed. That's why. You see that whisker on the left is longer because it's less skewed. Isn't that cool how you can quickly compare the graphs? I think that's all I want to say about the graph. So now we'll actually check conditions, run the test, okay? All right. Bless you. So I'm going to go to stat edit. I'm not going to input all the data. Can you just give me that one list of the differences? Sorry about that. I should have done that. Yep. Hold on. It said no. 220. 2. Okay. It said no. That's why. It's because I was hitting minus. 3, 1, 0. Hold on. -1. Okay. -1, 0, 2. Okay, thank you so much. All right, to check this, messing with me and my technology. Hold on. I don't know what y'all are doing. What's this magic happening? There you go. Okay. All right, so the issue is we don't have normality from looking at the graph, okay? So we can't say the graph has a normal distribution. It was less skewed. Then we looked at sample size. It is not large enough to use a CLT. So your third option, okay, is called the probability plot. So everybody watch. To get the probability plot, I do second y equals, and you might want to write this down. I have it written in my notes because I don't do it enough to remember necessarily after summer break. So when I come in to teach it, I'm like, oh yeah, how do I do that? So second y equals, and then I'm going to choose that first one. See if I can zoom this in some. Does that help? Can you see it better? Okay, so that's where my stat plots are, okay? So once you do second y equals and you turn that plot on, then you're gonna turn this on. So hit enter and then arrow down and to the far right. If you do this first one, that's a scatter plot. So that's linear regression. You'll notice the next one is a histogram. Got the distribution on here. The next one is a box plot that includes the outliers. The next one does not show you outliers. That's this one. And then the last one, which is the far right, that's your probability distribution, okay? Okay, so I'm gonna click enter on there, and you'll see now it's highlighted, and look what it changed. It said, okay, where's the data that I'm checking? You all need to make that a L3, because you have a L1, a L2, and then you use L3 to find the differences. Make that L3 on yours, okay? Once you do that, you're gonna click zoom 9, so that it shows you the stat graph, okay? Now, what I do want to tell you, when you have stacked ones like this, it's actually because you have multiple values there. So how many times did you say 2 to me? You don't have to count, but it was several, right? So we had a couple zeros, couple -1s, 1 -2 maybe, right? And so it's showing you how spread out the data is, or how many. So when it stacks it, don't get caught up on that thinking it's ruining your line. Because look, if I start connecting, there's a line there, yes? Okay, so this probability plot is linear. So you would actually take a screenshot of this and put this straight in your PowerPoint or straight in your paper for me or straight in whatever and show me the probability plot, okay? All right. Oh, I'm getting ahead of myself. Got my conditions? Nope. I gotta check independence. Good grief. Sorry, everybody. Tiff. Yeah, I got excited because probability plots are linear, so I was like, woo! Keep going. All right, how do we check independence? Something times 10, what? Good. Sample size times 10 has to be less than population. Sample size is 20 times 10, and that needs to be less than all college basketball players jump height, right? It's their height. You're measuring that height difference. In college basketball players, I'm measuring. Don't overthink it. Don't overthink it. That is technically, for being super technical, it's just on the differences between their vertical jump. The point is, do you think you can get more than 200 of those? Yeah. There's lots of college basketball teams. So, does it satisfy independence? Yes. Now we can run the test. Okay. So back over here, I'm going to click Stat. I'm going to arrow over to Test, and I'm going to choose T-Test. Good. So choose T-Test. Okay, what am I comparing this to? 0. I want to see if there's a difference. If I get negatives, then it means their jump went down. If I get positives, it means their jump went up, right? L1, your list is in L3, so hit second 3. Change that to L3. Then frequency is always 1. And what symbol did we have in our alternate? In our alternate we had greater than. So I'm going to choose greater than, and then I'm going to calculate. Now I have my test statistic and my p-value. This also gives you the mean difference and the standard deviation. Should I report those though? This data was skewed. Okay, so if it's normal, you can pull those values from right here to talk about it, okay? Excited about this, because it's not hard to make a histogram for the differences. You just put the data in and go to your insert graph. That's easy. It's this type, though, when it's a 2 stamp, okay? So I'm actually going to deselect that. I'm going to make this a list 2 and a list 3, okay? So L2 equals, you can do this with me, or if you feel like you can handle it without, you know, you don't have to. So 67, right? 67, 68, 68, 70, 72, 72, 73, 78, 80. You can just, you're running on your calculator? Yes, clear your list. I'm trying to make the graphical display first. You said to me, I'm sorry. Don't delete, clear. Don't delete, clear. Yep. 81, 83, 84, 88, 89, 90, 91, 92, 93, and 97. Okay, so I'm going to make a histogram for that. L2. Why is it yelling at me? Histogram. What'd I do wrong, y'all? Did I capitalize? And if you don't code stuff right, it like yells at you. Okay, why can't I see any of these values? Here. Ah, there they are. Do you think we should go by ones? What would be a good bin width? Sure. Okay. How's that? That's okay. I mean, that's fine. Or maybe I could go by 10s. What do you think? 5 or 10? You like 5 better? This is actually a preference thing, so I'm glad that you just you took ownership of it and said you like 5 better. That's fine. So absolutely do 7. However, a lot of times people are not as comfortable with 7s. Most people are comfortable with 5 or 10 because it's like I don't know, people can quickly 5, 10, 15, or 10, 20, 30. So it's up to you though. Either way, look, what kind of distribution is that? Okay, skewed, right? Probably, right? So what do y'all want to use? I don't want you to start drawing this until we finalize which one we want to use. You maybe want to look at the other data set because we need to use the same. So should we put L3 in there? The answer is yes, everybody. 77, what? 82, 82, 82, 84, 85, 87, 87, 87, 87, 88, 89, 90, 92, 92, 93, 93, 93, 93. What? Uh-oh, I'm missing something. 1, 2, 3, 4, 5. Please, can you give me just a sec? Good job knowing how to undo. Woo! Histogram. Do not capitalize histogram because it won't work. L3, comma 7. You want to go by sevens? You try fives? Try fives? You think that distribution's better? Yeah, okay, we're gonna stick with that. So I'm gonna pause the video for a second so that you can draw these. Now, when you present, I would recommend turning one of them off for a second. Screenshot that, then turn the other one on, screenshot that. Then, if you want, put them together and stack them so that you can see them. Okay? What is easier for you right now? You want me to turn one off and then turn the other one on? Does that help you right now? You're like, you feel Miss Errol? No, what do you need from me to help you with this? Why am I saying I would definitely make sure to get this if I screenshot it? Can you see what I'm highlighting right there? Can y'all see it? It's showing you the scale on the axis. The 5, the 10. I would actually just make sure if I screenshot, I would have it from here at the edge all the way over to there to show people, hey, that's a 5. You could count 1, 2, 3, 4, 5, but still, it makes it easier when you have that axis scale. Because you will be up in front of an audience. When you're far away, you think the white background's easier. Yeah, so everybody, the way she just showed me to change this is the wrench right here on the side. It says graph settings, and then I did reverse contrast. That's pretty cool. All right, well, since I'm presenting, I guess I'll leave it though. I did like the reverse contrast better though. It looks better on a screen, like on the iPad or on the computer screen, but if you're up presenting, it's really, yeah, it's not a good option probably. All right, so I go to stat. You can clear the list from here, remember, or you can hit edit and then arrow up and hit clear and then hit enter. Do not delete. Do not delete. That's bad, okay? So we had 67, 67, what? Thank you, 68. Why are you not working? Hold on, it's yelling at me. 68. 70. Every time it's like making that noise. Stop! Okay, can you put your data in there? Because this is not working. Yes, sir? My keyboard is whatty? It's coming, so it's like making that noise. Which would explain why I'm hitting buttons and nothing's happened. Check my keyboard. Okay, well the rest of you, go ahead and put the data in and look at the probability plot. Okay, so do second y equals, turn that plot on, right? Go to the far right and then look at L1, see if the probability plot's normal, and then, linear, and okay? You might want to use this giant jug right here, because that has a red light on.